friends, welcome to EK lectures. In this lecture we are discussing the probability distribution from statistical mechanics. We will be discussing about binomial, Poisson, Gaussian and normal distribution. Before going into the distribution, let us understand few terms related to distributions. First one is random variable. So random variable, let us consider an experiment. Experiment such as tossing a coin, tossing two coins. Okay, so tossing a coin is an event or an experiment, and the related outcomes are head head, head tail, tail head and tail tail. These are the elements of the phase space. Now let us take x, the variable x, as I am defining this variable x as getting a head. So getting one head as my variable, getting or let us write getting head or heads. We can write within bracket either head or heads, and there is no restriction about the number of heads. So it can be x can be, so x can be 0, that means 0 head. It can be 1 head and it can be 2. So x variable has 0, 1, 2 as the values. Okay, so this is called variable and this is a random variable, and the definition for the random variable is the possible outcomes, possible outcome of a random variable. So random variable is x, and 0, 1, 2 are the possible outcomes of the random variable. Now coming to the types of random variables, there are two types. One is discrete random variable, discrete random variable, and this is, let it be A. This is continuous random variable. So discrete random variable, we have seen the example x equal to 0, 1, 2, and continuous, it will have all possible real values. Okay, it is continuous, so the outcome of the variable will be, here you have finite numbers, but this is infinite. You can have any number of infinite values or infinite numbers. Okay, so here x equal to 0, 1, 2, and for here you can consider an example of real values between 2 and 3. So there are infinite number of real values present between 2 and 3, so that makes the variable continuous. infinite uh, and uncountable. Okay, now coming to probability distribution. Probability distribution. Now what is this probability distribution and how can you relate it with the uh, variable or the random variable? Now taking this experiment, tossing two coins, we have these following outcomes. Now in this following outcomes, if I write x as 0, 1, 2, that means 0 head, 1 head and 2 head. P of x, that means probability of x, is equal to probability of 0 head, probability of 1 head and probability of 2 heads. So here we can write probability of 0 head, probability of 1 head and probability of 2 heads. Now the probability of 0 head, so 0 head only 1 tt, this here we don't have any heads, so this is 1 by 4. Probability of 1 head, these are the case where 1 head, so 2 by 4. And probability of 2 heads, so that is 1 by 4. So total probability will be 1 by 4 plus 2 by 4 plus 1 by 4. Now the probability distribution says on x-axis you have x, the variable, and this is p of x. So for x equal to 1, 2, 0, 1 and 2, corresponding value of the probability, this is 1 by 4. So let us write here, let it be 1 by 4, here it is 2 by 4 and again 1 by 4. So this is the discrete, they are not discrete. So probability distribution, probability of the random variable and the random variable depicted or made in the form of a graph is nothing but the probability distribution. This is the discrete one, and for if it is from 2 to 3 continuous, so p of x will have some forms like this from 2 to 3. So this is p of x from 2 to 3. This is a continuous distribution, so this is a discrete distribution. So discrete random variable will lead to discrete distribution, probability distribution, while continuous random variable will lead to continuous distribution. So as discussed, the probability distribution, the meaning of probability distribution is a set of possible outcomes, these are variables, random variables. Okay, so set of possible outcome with the corresponding probability is called the probability distribution, and the probability distribution is a graph stating x and its corresponding probability p of x. Alright, so this is our probability distribution, and here again the probability distribution are of two types. One is continuous, let us start with discrete discrete distribution, and you have continuous distribution. Continuous probability distribution and discrete distribution. And example of discrete distribution is a binomial distribution. Binomial. And continuous is Poisson and Gaussian distribution. Gaussian or normal distribution, which is a special case of Gaussian distribution. So discrete distribution is followed by, is due to discrete random variable, while the continuous distribution is due to continuous variables. If the outcomes are continuous, then you have continuous distributions. Coming to what is discrete distribution. Discrete distribution of probability or probability distribution. So discrete distribution of probability or discrete probability distribution. Here few concepts or few ideas are there. We have finite number of outcomes. Like x, the variable 0, 1, 2, etc. up to n. Let us take an example here. The 2 coins that we have taken, head, tail, tail, head, tail. Here what are getting a head is the event. Getting head is the event, and this event has got x. That means this is the variable. Getting head is the variable. You can have 0 head, 1 head and 2 heads, and the corresponding probability p of x are 1 by 4, 2 by 4 and 1 by 4, and the sum of the probability, that is from sum over I, probability of xi will be equal to 1. So that's equal to here p of 0 plus p of 1 head plus p of 2 heads is equal to 1 by 4 plus 1 by 2 plus 2 by 4 plus 1 by 4 gives us 1. So total probability is 1. Now the concept is about the mean. Mean value is represented by the letter mu in quantum mechanics. We will be representing it by the value expectation of x or expectation xi. So these are the ways to represent the mean. Sometimes it's also represented by x bar. The way x bar, it mean represent the average value of the outcome. So that's it, average value of the outcome. and the expectation xi is given by sum over I xi into p of xi. So this is how you define the average value of the outcome. Xi, the average value is equal to xi times p of xi. Let us take the case of this. The average value of this variable 0, 1, 2. This is what we have to calculate. So that's equal to 0 into what is the probability, 1 by 4, plus 1 into corresponding probability is 2 by 4, plus 2 into the corresponding probability is 1 by 4, so 1 by 4. So this gives us 0 plus 2 by 4 plus this is again 2 by 4. So 2 by 4 plus 2 by 4, that is 4 by 4, that's 1. So average value is also 1. Now the average value of xi squared, so this can be written as sum over I probability of xi into xi squared. Let's take the case here. Xi is 0, 1, 2. Xi squared is 0, 1 and 4, and p of xi is 1 by 4, 2 by 4 and again 1 by 4. So expectation value of xi squared can be written as p of xi into xi square, that is 0 into 1 by 4 plus 1 into 2 by 4, this is 1 into 2 by 4 plus 4 into 1 by 4, so that's equal to 0 plus 2 by 4 plus 4 by 4, that's equal to 6 by 4, that is 6 by 4. So this is the average value of xi squared. So when you square the xi, you would get the average value of the distribution as 6 by 4. Now let us take a different case of throwing a dice. Throwing a dice. X is the outcome. What are the possible outcomes we have? It's 1, 2, 3, 4, 5 and 6. Now what are the corresponding probabilities? P of xi, that's equal to 1 by 6, 1 by 6, 1 by 6, 1 by 6. No change because all have equal probabilities, and this is called unbiased dice. Okay. Now let us find out the average value of x, that's equal to probability into 1, so sum over p of xi into xi, that's equal to 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, so 1 by 6 into 1 plus 2 plus 3 plus 4 plus 5 plus 6, so 2, 4, 6, 10, 15, 21, so it's 21 by 6. So on an average you would get, if you throw a die once or twice or thrice or many times, the average value that you are going to get is around the range 21 by 6. So here you can also find out xi squared, which will be equal to, you have to square it. On squaring, what you get, let us write here, x square 1 4 9 16 25 and 36. So 1 by 6, the probability remains the same, but 1 plus 4 plus 9 plus 16 plus 25 plus 36. This gives us 1 plus 10, 10 plus 4 plus 16, 20, 30, 30 plus 25, that is 55, plus 36, 91. So 91 by 6. So this is how you can get the expectation value of x and xi squared, or average value of x and xi squared. Now let us define probability. Suppose a very random variable here we are discussing about the discrete one. So every random variable has equal probability. Now let us assume that x is the random variable and x value starts from 1 2 3 etc. up to n, and the corresponding, if both are, if the all have equal probability, just like we have seen in the case of dice, it all have the probability 1 by n, 1 by n, and etc. up to 1 by n. Every probability, every random variable will have, every values of the random variable will have the same probability. Then you can write the average value of the x is 1 by n into sum of n numbers. So sum over I, let's say over n. Alright, so this gives us 1 by n into 1 plus 2 plus etc. up to n. So this is sum of n numbers. So n in sum of n numbers is n into n plus 1 by 2. So 1 by n into n plus 1 by 2, that's equal to n plus 1 by, so n and n get cancelled, so it is n plus 1 by 2. So this is the average value of for x. Then what next is expectation of x square. So that will be equal to 1 by n into sum over ni squared. So that's equal to 1 by n, sum of squares of n numbers. So 1 plus 2 square plus 3 square etc. up to n square. So sum of the squares of n number is given by n into n plus 1 into 2n plus 1 divided by 6. So n get cancelled, so that's equal to n plus 1 into 2n plus 1 by 6. So for the conclusion, for a distribution which is discrete, so for any discrete distribution, the mean value or the average, mean or average value is given by sum over p of xi probability into average value. Here we have to define the x, average value of x is equal to into xi, sum over xi into p of xi. There is now another concept, that is what is variance. Variance and two concepts together we can learn, variance and standard deviation. Variance is given by sigma squared and standard deviation is sigma. Now it's the definition is very simple, that is it gives the deviation of a random variable, deviation of a random variable from its mean value. Just take the example of dice. If I am getting for a dice, the standard deviation, the mean value for a dice is what you get is 3.5, so that is 21 by 6. So expectation x for dice is equal to 21 by 6, that is equal to 3.5. now I am throwing a coin and I am getting 5 as the digit. I am getting 5, and this deviation, so deviation is 5 minus 3.5. so from the mean value, the random variable is 1.5 times greater. Okay, this is just an idea of finding how much our variable is deviated from the mean value. Now coming to sigma squared, the value is given by sum over I into xi, that is our value such as 5, minus the average value of the xi squared into p of xi, its probability. Once again, this can also be written as I xi minus mu squared into p of xi. Now this is the sigma square, which is the variance, and sigma equal to root of sum over I xi minus mu squared into p of xi, and this is called standard deviation. Standard deviation also has the formula sigma is equal to root of xi squared, the average value of the xi squared, minus the average value of x squared.